So like we do other problems, we want to isolate the function first. So I'm going to divide both sides by 2. So now I have cosine pi over 4x equals 1/2. Now from here, I like to pause, ignore the pi over 4x for a minute, and just instead consider what if it instead was just the cosine of theta was 1/2. So unit circle, cosine's an x value. So x equals 1/2, so about there. So I get these two basic solutions here and here. So I'm going to call this first one there, theta 1. I'm going to call this one over here. See which way I want to measure that. I can go any way I want, but I think I'm going to go the more traditional route and go the first positive version of that solution. We'll call that one theta 2. Next thing I recognize is 1/2 happens to be a number from one of my special angles. If x equals 1/2, that looks like pi over 3. So I think theta 1 is pi over 3. So then the other version of that, so again, what I'm saying is that theta, or theta 1 here, is the arc cosine of 1/2. And from what I remember about the unit circle, I think that is pi over 3. For the other one, I can use that to come up with the red version because it's just that as a reference angle out of 2 pi. So I think I can also name theta 2 here. I think theta 2 is going to be 2 pi minus that arc cosine, which should be 2 pi minus pi over 3, which is what? 5 pi over 3? Six pi over 3 minus 1 pi over 3 is 5 pi over 3. Yes, that looks right. So now I've got those two basic solutions, and I can use those to generate other ones. Now I have to go back here and I got to rethink that pi over 4x. So for my theta 1, what I have is that pi over 4x is equal to, in this case, pi over 3. Multiply both sides by 4 over pi. Pi's cancel, and I get x equals 4/3. That's one solution. Do the same thing for the other one. Pi over 4x equals 5 pi over 3. Multiply both sides by 4 over pi. And you're going to get the pi's cancel, that's it. 4 times 5 is 20. I get 20/3 for that one. So those should be, given the order that I find them, the two smallest positive solutions. We've been asked for things like that before. This said find all solutions. So what am I going to do to make all solutions next?
2 pi n.
Almost. 2 pi n works when the period is 2 pi. So for these guys, the period was 2 pi. So I can make that work, but instead I'm going to do it slightly different. What I'm going to do is just think about what's the period of that one right there. So we know that P equals 2 pi over whatever that multiple is. I'm going to call it A. Or A, oh, no, that's what I want. Sorry. Erase. So P equals 2 pi over 4, which is 2 pi times 4 over pi. The pi's divide out, and the period here is 8. So 8 is what I need to generate other solutions. So then here I could just add on multiples of 8n. And with this one, just add on multiples of 8, where n is an integer. So I think that's the easier way to do it. First find for just a simple theta, two basic solutions. Then go back to your, whatever we have there, whatever multiple of x we have, to adjust, and then use the period to extend to other possible solutions going down. Alternatively, if you had that, if you like the 2 pi idea right away, then it would look more like this. You work with it a little bit different. You get to the point where you have like a theta 1. Theta 1 is, say, pi over 4. And theta 2 is 5 pi over 4. With these guys, you can add on 2 pi n. Then your next step would be to take that pi over 4x and set it equal to each of those. So like if I do it for the top one, I would have, oh no, we didn't have pi over 4, we had pi over 3, didn't we? Sorry. Race. Pi over 3, pi over 3, and it was 5 pi over 3, right?
Mm-hmm.
Okay. So then I would take pi over 4x and set it equal to each of those in turn.
And then you'd solve.
And then solve for x.
It still works as steps.
It still works. Yeah, I think this is more steps, doing it that way. So then I would have to multiply by 4 over pi, and the same thing, distribute the 4 over pi here, which equals pi over 3. Yeah, so it's more work, but this is a lot of times the way it's taught. Stuff will cancel like we had it before. And so then I'm going to get the 4/3 plus 8n. I still haven't got the other one. So the reason I do it the other way is here I'm messing with the period twice, and then there I have to mess with it 2 more times. Over here, I can just get it out of the way once and then just use it. So it's just a little more efficient. So then my solution set would be this right here.